All right, I'm going to go ahead and get started. I appreciate everybody joining us today. We've got the chat box if you want to put in questions as we go along. If they pop in and I happen to be paying attention, I've got multiple screens going on here. So if I can see them come in, we'll handle them at that point in formal groups. So feel free to jump in with those questions at any point. My name is Bryan Prince. I'm a consultant, a workflow and lab design consultant. I design projects like this one you see behind me. This is a project that we've recently done. It's a great project, about 1,800 square feet of compounding, all aspects of compounding. We'll talk about that and get more deeper into the weeds. Probably 9 out of the 10 projects that I do are independent community compounding pharmacies. And my goal was to help them really demystify this whole thing called USP compliance from a 503A perspective. Occasionally I may do a 503B, and that's the 1 out of 10. So understand that where I'm coming at from today is from a 503A perspective and help you kind of decipher what is USP compliance as it relates to facility and engineering. I came from a construction background. My grandfather built houses after World War II. My father, he's an electrician. So I grew up knowing which end of the hammer to hold on to, and I'm not bragging. Of course, after I graduated from college, first kid to go to college, I went right back into construction. Rode that for a decade until we had this wonderful thing happen in 2006, 2007. You may have seen it. We had the housing bubble crash, right? And so I had to kind of figure out what I was going to be when I grow up. And at that time, I started working for a company that designed and engineered containment. And really what that is that's controlled environments. I've spent a lot of time at Merck, Glaxo, Johnson & Johnson, Hospira, Bausch & Lomb, those type companies. And then along the way, around 2013, I got introduced into the wonderful world of compounding pharmacy. Was very intrigued by it, started writing technical papers, started getting invites to speak at conferences, and that's where I am now. So I'm my own independent consultant, and I enjoy so much what I do here. Let's see if I can get my technology working. There we go. My disclosures, I'm not getting paid by any of these companies today to promote their products, so the pictures that you see, inconsequential. And so I just want to let you know that I have no commercial conflicts. So let's talk a little bit about the historical perspective. Every one of these pictures are my fingers. Some of you are saying, oh my gosh, I can't believe you weren't wearing gloves. This is what I do. I like to live on the edge. I'm a danger kind of guy. So one of the first compounding pharmacies I went to back in 2013, you can see they had probably 4 or 6 what we know as powder hoods, class 1 biological safe cabinets, CVEs. They go by a lot of different names. And yet I was still finding powder on cabinets and countertops and stuff like that. And that was actually the case at every single one of these environments as I adventured through them. And you can see I've taken this picture for the past 7 or 8 years now, and I've taken it so many times over and over and over. And I can tell you that I could probably walk in your pharmacy, not trying to beat you up or jump on you for bad practices, but more than likely our people are not using the controlled engineer environments that we've given them access to. So as you go through this, we're going to talk about how to design a lab, but I'll tell you, you can spend as much money as you want to. Sky's the limit on how much money you can actually spend designing a USP compliant environment. And the reality is that if your people are not using the controls, the engineering controls, the hoods correctly, they're breaching containment, they're doing these things, then all that money you spend is for nothing. I'm the guy who actually goes around to the pharmacies, and I carry my little flashlight. You can sit down at the bottom. You can get one yourself for $12 at Amazon. If you're an Amazon Prime member, it'll ship for free. And by the way, I don't get paid on flashlights, but I ask you to please look closer at your facility, see what's truly going on, because this is at the heart of what I do here. I'm really a safety guy. I was talking about aspects of USP 800 before there was a USP 800. And I remember the first conference I spoke at, it was either late 2013 or early 2014. I had like 10 people. Now people are starting to listen to this thing called environmental exposure, personnel exposure, which is one of the reasons why we've got a USP 800. So I won't beat that up too terribly much. I just wanted you to understand kind of where I came from in this industry. So moving forward, we've got 4 distinct areas of compounding, and I like to kind of break those apart. USP 795 and USP 800 non-sterile. Both of them are non-sterile. The intent of the chapter per 800 is that we separate hazardous and non-hazardous compounding. Same thing on the sterile side. So you can see 797 and 800 sterile. They're broke out in their own quadrant as well. Each one of these has their own controlled environment. USP 795, actually the 2014 version we're operating under now, as well as the 2019 version that at some point we'll be operating under after the BUD situation, we can still do open bench compounding, which I never condone that by any means. If you're handling any API or powder, you absolutely need to be doing inside of an engineered environment. But you can see we've got very lax standards. Even those same control standards for the room carry over to 800 non-sterile, except for now we have to have a room with fixed walls, negative pressure, certain number of air changes, and then get that air out of the building. And we're going to talk more about that because getting air out of the building is a really big deal. And then moving to USP 797, not a lot is changing. It's all positively pressured. We're recirculating that air if we so choose. We can kind of flow it out as we deem. But then 800 sterile, again, negative pressure. We got to pump it out of the building. So I show you this to help you understand that you just don't want to treat everything as hazardous, right? You actually need to distinctly break these pieces apart. That is your best practice, and we can kind of debate that a little bit later. But let's also talk more about what that looks like. I like to design my spaces, these rooms, in a 3-dimension, put people in it, put our chemicals, put our hoods in there. I think it really brings life to the projects and gets people excited. But this is a project that I recently did up in the northwest of the U.S., and it really brings life to those 4 quadrants. So our USP 795 area, non-sterile, non-hazardous. USP 800, non-sterile, hazardous. And we're going to get that air out with these low wall exhausts. We'll talk more about that. And look at this gowning room. By the way, you're not required to have a gowning room. Some people call it an ante room. You've got to be careful with our language. It's just a good practice because I love teaching technicians that donning and doffing of both primary and secondary PPE should really be happening in different places, but that's not required. Now, moving into our ante room on the sterile side, I can go to my pre-sterilization weighing for my sterile non-hazardous before I go into my buffer. And then on the hazardous side, again, pre-sterilization weighing before I go into the final buffer. We now know this is high risk. That means we're starting with a non-sterile API before we go and we do final terminal sterilization. So I show you this model, not to impress you with my 3D graphic skills, but to show you that even though we've got 4 quadrants or 4 different aspects of compounding, what we could actually be looking at is a series of different rooms to understand how do we break these parts into these pieces apart. So we're going, wow, I don't have this much room. We may need a new building. And we go through all this. And where this is important is moving to our next slide. If you're working with a general contractor right now or an architect or even a modular wall company, and you're planning what the future of your facility looks like, how do we comply with USP 800? We're thinking about getting into sterile. All of these different things that come up, we got to step back. You don't just say to that modular wall company, hey, I've got a 20 by 20 space. I've got a 60 by 30 space. They're going to sell you walls. They want to sell you walls. That's what they do. Not to beat those folks up. They're great people. Your architect's going to throw up walls for you. You need to step back from the business model. The business model that at your pharmacy is at the core of the decision before we even start laying anything out on paper. And if you look at this project here on the right, another project, this was down in the southeast, and we step back and we go, tell me about your business model first before we start drawing anything. So I implore you, please, to do this first. Let me give you an example of what I've got here. 100, this is my pharmacy example, 100 compounded prescriptions per day on average at this pharmacy, and we're growing at about 10 to 20% per year. I looked back at our business model for the past 3 years to where we are now, or 2 years where we are now, and I'm starting to see some growth, maybe my HRT, maybe my pediatrics, maybe my podiatry, maybe something's growing, but I'm looking at the growth model. And then I'm going to pull out my magic crystal ball that I always have in my desk. I'm sure you have one as well. And I start projecting the future. Are there dermatology surgeons 20, 30 miles from here that I haven't met yet? Are there women's health specialty providers that I know that I need to get in front of and talk to them about HRT? And I want to start projecting what my business is going to look like. So at this business, USP 795, simple pediatrics, simple topicals. Let's say maybe you can put your pain in there. Use gabapentin, not only the NIOSH, right? You do stuff like that. And that represents about 30 scripts per day. The 800 non-sterile represents 60. That's going to be most of our HRT. We're going to throw some methimazole in there for our kitty cats, maybe some tretinoin for dermatology, anti-aging, or acne. And that represents, you see, the lion's share of where we're at. Now we move into 797. I've got maybe some simple eardrops, maybe some TPNs, eye drops that aren't serum-based. And then USP 800 sterile, 5 scripts. Let's call that testosterone injectables for the sake of argument. This is how my script ratios break down. And I understand that as my business model. And I'm going to divide my spaces and think about that. Now, let me just kind of focus right here on these 60 scripts. I know that one technician in one hood could do anywhere from 8 to 25 scripts per day. Now, that's a huge variation. 8 on the low end is where I'm getting one-offs, one-off. We're having to clean stage, compounding records, print those, get them, and that takes a lot of time. So I'm doing about 8 prescriptions per day. Maybe that's also a new technician. On the high end of 25, I've got the same women's health specialty provider. She's writing the same T3 or the same progesterone script over and over and over, and I can build what we can do as anticipatory stock, that I can prove that. So that could possibly be an upwards of 25 scripts per day. So in this scenario, I may need 2.5 or 3 technicians and 3 hoods. And that business model for me has been growing. So what I'm hearing out in the market are some wholesalers or some other consultants are saying, listen, you need to make your hazardous drug space as small as possible. I get that, right? If we're throwing perfectly good air out of the building, we're externally exhausting that air per USP 800. It's expensive, right? Nobody wants to throw good air out of the building. However, nobody also wants to back themselves into a business model that you can't get out of, right? So if that business model for you is growing and you build that room as small as possible, 3 to 5 years from now, or even now, you've capped yourself into a place that you can't grow out of. And so what you've actually ended up doing is hurting your business. So we'll agree to disagree that, yes, we need to make that room as small as possible because it's externally exhausted. That's going to be expensive, but don't hurt your business model. So this may be the most important thing you see today. If you're planning on going into a remodel or a new construction project, think through the business model before we start putting up any walls whatsoever. I'm not seeing any questions, so feel free to say, hey, that's a great point. I just want to make sure my chat box is, so if anybody just wants to jibber jabber something on there, I'd appreciate that. So let's build a room, a compounding space from the ground all the way to the roof, and we'll kind of stack this building. We'll start with the floor. There's 2 things that USP define that are acceptable, right? Number 1 is homogeneous sheet vinyl with heat welded seams, and that's what you see right here. It's rolled up the wall. It's perfectly coved. I love that. They put a little cove reinforcement behind that you can't necessarily see, but that makes my life cleaning that floor every single day, which I've got to do, a lot easier. So I really like this vinyl. This epoxy, this is one of my projects on the West Coast. They did a great job on this. I really appreciate it. They actually put a little cove strip and epoxied over that to make it easier to clean. I will caution you, though, about epoxy. The cement slab that epoxy paint goes on top of has to be grinded to a perfect perforation or texture or whatever it is. We've got to do moisture sampling. And I actually have seen epoxy paint failing in the market because it was not applied correctly. It's very pretentious about how it's applied and where it's applied to and how many layers, how many mil thicknesses. So I would tell you that it is perfectly acceptable. However, it will also off-gas. It smells bad for about 2 weeks. That's just neither here nor there. So I would tell you, I like vinyl. I think it's a great product. And honestly, thinking about the 2 and long-term capabilities, vinyl is going to be your best. But again, I just want you to see that both of them are perfectly acceptable materials of construction. Now, the walls, let's talk about the walls. I'm a huge fan of modular walls. I think they're great. Look at this flush glazed glass, and I'll talk about more about the flush glazed glass. This surface is smooth, impervious, easy to clean, free from cracks and crevices, and non-shedding. That's the great thing about the modular walls. And if you look at what I've written here, due to the difficulty of cleaning hazardous drug contamination, these surfaces have got to be of this type stature. And I really don't like this word cabinets, and I don't know that I have a picture of cabinets. I'm going to jump ahead of myself a little bit. Cabinets were the worst thing anybody ever put to a compounding pharmacy. My opinion, Brian's opinion, because I'll take my little handy-dandy flashlight and I'll shine it in there and I'll show you that's some of the dirtiest places. So I like an open shelving concept, Brian's opinion, but they did put it into and saying, yes, they just need to be smooth and pervious. Some of your melamine and your laminate cabinets will fail over time. I'm not going to beat that up. But here's your wall structures right here, the modular walls. Now, modular walls are more expensive, no doubt about it, versus stick framing. I'll show you the stick framing example. But look, out of the box, they stand it up, boom, it's good to go. It looks great. But understand, it is much more expensive to deal with. Now, let's look at its alternative. This is called stick framing. Now, let me just tell you right off the bat, when you see this, I am not a huge fan of wood studs. And the reason why, wood is an organic material. When I came back from the home building business and the commercial construction business, we had the sick home syndrome because wood acts as a food source, as an organic food source for mold and mildew and all of those other things. So we've got to be careful. So I'll tell you that if you are going to stick frame, do it with metal studs. Metal studs are really not much more expensive. They're easy to put up. You don't have to drill holes for electrical conduits and stuff like that. Really great. This project just happened to be all non-sterile, so I was okay with that. They had already done it. I kind of came into the project late, but let me tell you, wood studs are going to be much better, especially if you're building an ISO-rated environment. Natural laws of vapor pressure are that natural vapors from outside higher pressures won't come inside, plus you've created a really cold space. That's what a clean room is. And it naturally creates this sponge effect for vapor and for moisture. And so organic organic wood studs are just a bad karma. And you also want to put up, and I did put in this, so I'm telling you this, you want to put up a vapor barrier or some sort of plastic to keep that outside moisture from resonating into that cold clean room because of natural laws of vapor transmission. And by the way, I have a tendency to talk kind of fast, and the reason why I've been given about 45 minutes here. I may get through early, I may not, but again, feel free to put your questions out there, but I do talk a little bit fast, so I apologize for that because I'm up against the time clock. Now, let's say that you do stick frame with metal studs and you put up that gypsum substrate. We know that is drywall, and that actually would have gone on those wood studs that you just previously saw as well. Once that gypsum goes up, we've got to mud it, we've got to tape it, we've got to sand it. And I will tell you that drywall dust goes everywhere, and it takes weeks for an HVAC system to cycle that drywall dust because it's like it just never stops. That's just how drywall dust works. And so you can also put up epoxy paint. I'll show you that in just a minute. But what I like better than that is these FRP panels. They come in these 4x8 sheets, and you mud the back of them. Anybody knows what liquid nail is? Liquid nail actually comes in a tube. It looks like a caulking tube, but it's called liquid nail. That will start to delaminate. You actually have to mud this product. So it's a little bit more labor intensive. When I say mud it, it's almost like you're putting down tile in your house. They're actually going to cake it. They're going to trowel it. That's the word I was looking for. They're going to trowel it off and then get this against the wall. But look at how much smooth and pervious, free from cracks and crevices, and easy to clean. And we caulked the things. I thought this installer did a phenomenal job with this project. Nice caulk bead at the floor. This is actually a resin flooring. But FRP panels probably run $40 to $60 a sheet, whereas epoxy paint is going to go minimum of like $150 a gallon. So honestly, the time that somebody has to roll multiple coats at $150 a gallon versus these, which are a little more labor intensive to put up, you maybe had a wash. These are going to clean up a lot better. What this also does is it keeps you from having to sand all that drywall extensively and getting it smooth to put the epoxy paint on. So just a huge fan of this product. So now we went from the floors, we're going up the walls. We're going to talk more about epoxy paint, which is a wall application as well. I showed you that on the floors. This is a wall application. Now, I want you to understand that not all epoxy paint is created equal. I talked to you earlier about some of the products with putting it on a concrete slab. Kind of the same thing here. Pre-catalyzed, fair product. Catalyzed, a little bit better product, but then two-part high-performance epoxy is an even better product. You can actually see they've actually got a healthcare setting here on their brochure. I have no affinity. I have no commercial relationship with Sherwin-Williams. I just want to show kind of a good, better, best. This product called pre-catalyzed, I saw it recently. It was behind a sink, so where we're washing our capsule plates, our mortars are pestle, maybe we've got taller glassware, and as we're washing those, we're getting this backsplash on the wall. And this pre-catalyzed product peeled right off the wall and created a major ugly problem that had to be repainted. So eventually they went up there, put a metal backsplash to kind of fix the issue. But the reality is understand epoxy paint is always not necessarily meant to get wet in some form or fashion. And quarterly, even in your non-sterile environments, we've still got to clean the ceilings and the walls, right? So understand that how much we saturate those things is going to depend on the long-term performance of those things. So epoxy paint is certainly an approved material. I just caution you and tell you to be careful with the epoxy paint on the walls. So, glass considerations. Most state boards of pharmacies want to know that the pharmacist has some form or fashion of visibility into all the spaces where drugs are being handled, which means also our compounding spaces. So you can see glass is a good thing. This just happens to be one of our projects where it was full view and they got full transmission of everything, really great. Kind of maybe a little bit of an overkill, but it's all flush glaze, so they can, you know, it's all smooth and impervious. But I show you this to tell you that this is a locally sourced product at one of the projects. They tried, right? They actually dropped the commercial glass in what's called a U channel, but they didn't anticipate the thickness of the drywall. So you can see that there's about 5/8 inch or maybe 1/4 of an inch of drywall that's shown. They went back and caulked that, made a good clean caulk line. USP 797 says minimal ledges. What does minimal ledges even mean? Nobody knows what is that, 1/4 inch, 1/2 inch, 1/2 foot? Nobody knows what a minimal ledge is. Again, USP leaves some things subjective for us, and we kind of have to read between the lines. So you can certainly also source it locally as well, but visibility is important. So the goal of that visibility is so that the pharmacist in charge or the lab manager or whomever you've got out there who's doing verification, say the pharmacist is doing the verification, they want to be able to get full visibility, especially from competency assessments, right? We got to get really tight on our competency assessments moving forward in this new regulatory world. My friends at the ACHC, the people at the FDA, they'll all tell you, if they were here, they would say, yeah, we would all agree that one of the major areas that we see is lack of documentation on competency assessments. And you can easily achieve that without having to don $5 to $7 to $10 worth of PPE to go into the compounding environments, stand right at the hood and watch all the technique. You can actually do that through visibility. So I'll tell you that glass is really an important part of the design considerations for your 503A facilities. Now, we've gone up the walls. Let's get to the ceiling here. Our ceiling's the same thing. They've got to be smooth, impervious, easy to clean, free from cracks and crevices. So we want to know that if I'm walking my clean room mop down the ceiling as part of my cleaning protocol, that I'm not going to start snagging that on a lot of things. Sometimes the fire marshal makes us have certain crazy little strobe things that penetrate, but all of your sprinkler heads need to be above the ceiling, and they've got what's called pop-off heads, which means if the water engages the head, and you can actually see one of those barely right there above the word integrity, that's going to be a pop-off head. We've got gear drop dampers. We've got all these things. We've got flush glaze lights. These are our diffusers, our laminar diffusers. So look how smooth and clean that ceiling is. Now, moving forward, let me talk to you about vinyl face tiles versus gypsum back tiles. Moving forward with USP under environments, we've got to hold this negative pressure to 0.01 inches to 0.03 inches of water column. That's a very tight margin of error. And I can tell you, test and balance folks, which come in after the mechanical folks, they're having a hard time landing that number. They're doing pretty good with it, but we've got to give them maximum control over the space with dampers and all of these other mechanical things, kind of the unintended consequences of USP 800. But if you use vinyl-faced paper-backed tiles, they weigh, this 4x8 paper-backed tile weighs about 1 pound. So it's not very heavy, which means I've got to clamp it or caulk it, because the integrity of the envelope, and when I say the envelope, that's the room is the envelope. That integrity to minimize cracks and crevices where air can infiltrate or exfiltrate is super important. And so a 1 pound tile is not giving me that natural compression on the ceiling that I'm hoping for. So I tell folks to consider a vinyl-faced gypsum back tile. Those 4x8 tiles weigh about 14 to 16 pounds apiece, so they're very heavy. What that is when they're laying in that grid, and this is the grid work, it's getting good natural compression that would then maintain the integrity of the envelope, so you're less likely to have to clamp those from the top. If it's a clean room per USP 797, we still got to caulk. And caulk is such an ugly thing, especially if you've got a person who's running a caulk gun who's not very good at it. So I tell general contractors all the time, please put your best caulk guy on this job, because what we don't want is a bunch of ugly caulk gooped up all over. Just really, it looks bad. But it has to be done, right? Because again, we got to maintain the integrity of the envelope. You can also do what's called a hard lid. A hard lid would be gypsum, right? I'm actually putting the gypsum, which is our drywall, up, screwing it in, taping it, mudding it, and then I'm going to epoxy paint that as well. You can certainly do that as an alternative. That's called a hard lid. But then what I found is that your fan filter units and your lights have a little bit of a lip, and they don't actually sit as flush as a grid. So I like drop ceilings a little bit better. Plus, I know that if there's ever an opportunity or a situation where I have to do mechanical maintenance to the fan filter unit, let's say that the motor goes out on it, hypothetically, or I need to do some adjustment to the system, or I want to inspect my ductwork, my mechanical stuff, it's so much easier to pop a tile. I can actually score that caulk line with a utility blade, pop that ceiling tile, climb up in there, do any maintenance, maybe an LED light gets burned out, but very unlikely. As opposed to a hard lid, you better have a mechanical access door out in the hallway or like an attic access door. And some people will put these metal access doors on the ceiling. And I'm not real fond of those because it's another penetration into my clean room, which I really don't want. So I am a huge fan of the drop ceilings. I just think all in all, they make life a lot easier versus the hard lid, again, which is the gypsum. So here's where we're going to talk about the lights. I see a lot of these halogen lights. I actually saw this light fixture recently. A little bit of a story there. I'm going to check my time. Okay, we're good. We're only at 30 minutes right now, or 25 minutes. A friend of mine sent me these pictures saying, hey, I just got approved by the state board USP compliant. First of all, I didn't even realize that state was even inspecting to that standard, but they were for whatever reason. I think maybe it was a little preliminary. I said, all right, cool. Send me some pictures. I'd love to see, you know, how it shaped out, because I actually didn't consult on the project. And this trofer, or this light fixture, is exactly what they had inside of that USP 800 as a non-sterile environment. Now, I would ask you, is that smooth? Yeah. Impervious? Maybe. Free from cracks and crevices? Easy to clean? No, it is not. So if we're looking at the true definition of how USP 800 and even USP 797 define some of those building materials, I would tell you that that light fixture is not easy to clean, because you're going to have to get up there and clean that thing by hand, as opposed to what we call a flush mounted LED fixture, which I can just run that clean room mop right over that, over the face, and not have to worry about it. So I would tell you that not all light fixtures are created equal. This light fixture cost about $68. This light fixture cost about $198. So you can see, yes, to get those approved materials, they're going to be more expensive. Even those ceiling tiles that I talked about a moment ago, the gypsum, they are twice as much as the paperback tiles. But what are we trying to accomplish? Now, I'm not trying to blow your budget by any means. I'm just giving you the highs and the lows and the bumps and the bruises of these projects that we've seen out there in the market and what's actually happening. Ultimately, your budget is going to drive your design and your materials criteria, and I certainly respect that, and I get that. Here's my cabinet doors I was talking about earlier. Remember earlier when I told you I think cabinets were the worst thing that ever got put into a compounding pharmacy? They are. Then I like to take my light and show folks that is actually the dirtiest part of the lab, because we think that those doors somehow create this magic submarine hatch, and they really don't. And look, this is called a laminate or a melamine, and after time they get damaged. Maybe I bump them with a cart, or I keep slamming them. And look, that is exposed particle board. Look down here. This is also exposed particle board as well. That's a shedding surface. So I would tell you that this is probably not, by definition, USP compliant. USP 795, yes, but USP 800 and 797, the answer is no, it is not. So what are those accepted materials? You can do polypropylene. I'm not a fan of drawers either, but polypropylene, it's very expensive. We've got our stainless steel shelving. Great product, nothing wrong with that. It's got this little lip here, so now most of my stuff is not going to fall off. You just have to kind of drill into your walls. We've got stainless steel base stands, and then we can also put phenolic. And this black surface, this is a phenolic. That's it back, if you remember back in our chem days in college, or maybe even high school laboratories, they had that hard black surface. It's basically almost bulletproof. It's impervious to any of your chemicals that you can spill on it. We're not dealing with too terrible stuff, but good stuff. Epoxy surfaces are also well. I also see people that do corian, or solid surface corian, like you would have in your home. I would tell you those chalk on the bottom. If you've got corian at home, rub your fingers on the underside of that corian and see if it doesn't chalk a little bit. That I would consider as a shedding surface. Could you possibly cover that? Maybe so, right? But just be careful with the surface. This is actually painted metal now, or powder coated metal. Let me tell you what's going on with powder coated metal. It's an accepted surface, but you got to be careful with our Paradox RTUs and our other heavy peroxide hydrogen, even IPAs, they all leave what's called a surfactant, which is like a sticky type surface. So after you clean and you do your dwell time, 2 minutes, 5 minutes, whatever that dwell time is, you got to understand that they leave that surfactant, and that is actually what's going to start to eat away. It'll actually start to eat away. Some of those will actually start to eat away stainless steel. This is 304 stainless steel. It'll start to pit it out, which means you'll start to see little rust spots. So I would tell you that if you are using to deactivate, decontaminate, clean, and disinfect, the DDCD process moving forward with 800 as it's defined, you got to be careful with any and all materials because it will pit it out and it'll start to deteriorate it. And the things that we do not want in our pharmacies is rust. The three things that the FDA loves: rust, dust, and hair. So be careful with that. So what's the solution to that, to those materials? You can go back with an IPA. Now, if you're in your clean rooms, you want to use a sterile IPA. You want to pull up that surfactant. Now, remember I told you IPA can also do that. It takes a lot more of that surfactant, or that residue rather. So you can also go back with sterile water and then do a post-wipe periodically. You don't have to do it every single cleaning protocol, but periodically your goal is to remove any of that residue off of those cleaning materials so that they don't start to rust out. So there are solutions, there are workarounds. Yes, it's going to be much more labor intensive. And some of you that are maybe jumping back and forth between the 503A and the 503B surface, you're going, I'm hearing the same thing over there. It kind of is, guys. There's not a lot of easy way out here, right? The FDA wants to see that we are abiding by these CGMP rules, right? People in, product out. One-way traffic. Don't overlap, your compounding records and your finished goods. That's in process and finished goods. We don't want them overlapping each other. So there's a lot of logistics that really goes into the facility design and the materials of construction. There's maybe a lot more. You're like, I had no idea that simple 503A, non-sterile, non-hazardous compounding was going to walk me down this path. Again, I call this some of the unintended consequences of USP 800. It kind of is what it is. And again, you see, I have a tendency to kind of get sidetracked with other stories. They got a lot of really great stories. So now let's move above the ceiling now. So we've gone the floor, we've done the walls, we've done the ceilings, our lights, all of that. And let's move up ahead. In our clean room environments, as well as USP 800 non-sterile, we're moving a lot of very expensive air. We've got dedicated makeup air units that's trying to maintain for your clean rooms below 20C. We know that is 68F, but we're actually going to target 65 degrees. And the reason why we're going to target that is because I've got technicians wearing rear tying gowns, double shoe covers, double gloves, hair bouffants, and they're in there sweating at 68. So we're going to target 65. So I've got some very expensive air moving down this ductwork. So I can tell you that cheap flex is a no-fly zone. We absolutely do not want to use cheap flex. That may work in your house, but if you put it in a clean room or a USP 800 environment, very likely it's going to get damaged. It's not going to hold the pressures. Actually, under certain negative pressures, this could actually collapse. And that then pinches the ductwork, and you've messed up all your airflows. So I would tell you that inexpensive ductwork, so if you're having conversations with your local HVAC people, no-fly zone on the cheap, inexpensive fiberglass ductwork. We want to use metal ductwork. Now look how they've sealed all of these things. We call that in the industry, we call that pookie. That's a fun word. It's also called duct sealant. And so when they put these things together, they want to make sure that they are sealing all of that ductwork. Now we can't leave this ductwork exposed because the interstitial space, which is this space above the ceiling, may be, let's call it 118 degrees in the middle of the summer. And then this duct line right here is moving 60 to 65 degree air. What's going to happen? It's going to hit dew point and it's going to start to drip. So that's when we actually would take duct liner, fiberglass duct liner, and we're going to wrap this ductwork. We're actually going to insulate this ductwork to make sure that it's not going to start dripping, and that it actually does, because this ductwork, metal ductwork, will actually absorb whatever that temperature is, which will actually then change the temperature of the air inside the ductwork. So you see, there's a lot of logistics going on. So I can tell you, yes, fiberglass is okay, only if it's insulating this ductwork here. And this clamp style is kind of expensive, but I've seen it as well. So our materials of construction, this is somewhere where you don't skip out. I tell folks that the heaviest, most labor-intensive process with USP 800 as well as any clean room, as well as financially, the most heavy lift is going to be on the mechanical side of the equation. And when I say mechanical side, I mean ductwork and I mean air handlers. So this is what our ductwork needs to look like. These are and the reason why I share this much intimate information with you is because you need to be able to have very intelligent conversations with your general contractors and your HVAC people. What I see across the country are HVAC people who go, yeah, man, we built chiropractor offices. We've done dentist offices. We've actually done work down at the hospital. We know exactly what you want to do there, Mr. Cool Consultant Guy. That's me. The reality is that USP has created a different animal for us. So great that they've done work down at the local hospital on the ORs or wherever, or they built dentist office. USP is a different animal. And so we got to make sure that they understand on how we're putting this stuff together. This is where I spend the majority of my time, is dissecting this for HVAC people. Now, let's talk about USP 800 just for a moment and how we're going to create negative pressure. Now, both Table 1 and Table 2 both say that we've got to externally vent that negative pressure space, that hazardous drug room. Now, what that means is that we're taking perfectly good air, we're pumping it out of the building. Now, I went back to my friends on the USP Expert Committee multiple times, multiple conferences that year. I said, explain to me what is meant by the terminology externally exhausted, externally vented. And they goes, out of the building. Okay, I get that. How much of that needs to go out? And they always say, all of it. Okay, all of the air. That means that we've got what's called one pass air. So I've got this big unit right here. Let's see, I'm swirling my mouse over it. It's an Aeon unit. That's taking outside air. And this project was down in the south where I live, where all people talk just like I do with a little bit of a southern accent. And it's taking that 78% relative humidity, moist, thick air in the middle of the summertime. We'll call that July, August at 96 degrees. It's pulling it in from the outside. It's super cooling it down to about 46 degrees. And then it's reheating it back up just to get it back to 65 to put it into our clean room. So think about that. And the reason why it's doing that, it has to wring all of that moisture out of the system. If those coils are not wringing that moisture out of the system because it's not built for that, then we've got a major problem where we've got excessive moisture in our clean rooms. And I get that call all the time. Hey, man, we can't maintain our temperature and humidity standards in our clean room. It's because the engineer and or the HVAC person did not specifically size the makeup air unit or the dedicated air handling system specific to that environment, specific to the zip code, referencing all of these other things. We call it an ASHRAE table and a psychrometric chart, all of these other things, right? You just don't buy a standard package air handler and stick it on a compounding pharmacy and expect it to work. That's not how it works at all. And so I want you to understand that if you take all of that air, now look at this guy, this is called a snail shell, or we call it a utility set exhaust port. I'm taking all of that perfectly good air and I'm pumping it right out of the building. Now, I like to use this example. Maybe this is a bad example, but I use it. Imagine you've got a bucket full of water, right? And you're holding it in, and you dump it out into the grass. Is there any way for you to rekindle that water back into that bucket? The answer is no, you can't do that. And that's the exact same thing that we're doing with our USP 800 clean rooms and or non-sterile compounding environments. We're conditioning outside air. We're putting it in the space, and then we're pumping it right back out again. There's nothing about your existing air handling system that was ever meant to do that. That's not how your air handling system works. And I could bore you to death for hours on how air conditioners work. We're not going to do that here, obviously. So I want you to understand that if you're currently having conversations with HVAC people, with architects, with engineers, with a general contractor, with anybody, because you're planning this USP compliant thing moving forward, this is the biggest thing right here. And this is going to hurt your feelings. My friends at the ACHC, when I speak at all of their PCAB workshops, they call me Bad News Bryan. And the reason why is that I'm the guy that gets to tell you all the bad news. And the bad news is how much this piece of equipment is going to cost, because it's going to hurt your feelings. And again, these are the unintended consequences of USP 800. We had no idea. But even setting USP 800 to the side, I hear this a lot in USP 797 clean room environments, where we can actually recirculate that air, but they're not doing it properly. And the coils inside of the system weren't meant to wring the moisture out. They weren't meant to circulate that air and change the temperature significantly. And I get those calls. I got 2 last week. So I'm telling you the thing that you don't want to skip out on. I've told you that this slide's very important, and this slide's very important. All of my slides I think are important, but this one is also very important, because what you don't want to do, this is the story I got last week. I told them in the very beginning, a friend of mine sent them a price. It was a $28,000 makeup air unit for that piece of equipment, and they cried. And I get it. $28,000 for this clean room air handler. Yes. So what they did is they decided to let their HVAC guy talk them into a $6,000 system, 1/3 basically, or 1/4 rather. And now they're calling me again, going, Bryan, our humidity in the space is going up to 86% consistently, because a standard package air handling system was not meant to do the kind of work. Think about it. In a clean room, we're changing out that air 30 to 45 times an hour. That's every 90 seconds to 2 minutes. Air handling system, a straight package, was not meant to do that kind of work and also bring in some percentage of fresh outdoor air. So we got to be careful with these engineering systems so that you don't throw good money. And now they're wondering, this story that I was telling you, what they're going to do with a $6,000 package system that's not doing the job they need to do. So there's a lot of other stories behind that, but I'm not going to bore you to death. So again, I'll tell you that this slide is very important. Now, what's the problem with negative pressures we've been discussing? Well, it certainly does suck. There's a joke there, and usually if I'm at a live conference, people laugh. If you don't laugh, I tell you, you got to laugh at my jokes because I'm the speaker. CFUs, bacteria, in a negative pressure clean room, thank you, Seth, for laughing at that. I appreciate that. CFUs, bacteria counts come from everywhere. And when we have a negative pressure environment, think about this. I've got a cold box at 65 degrees at 40 to 45% relative humidity. I've got natural laws of vapor transmission, and that box is under negative pressure. It's a virtual sponge for whatever's happening outside of that, right? So that means that it wants to pull stuff in. So I got to tell you to be very careful about how you place these rooms. And this is actually a good example that we encountered a couple of years ago. Now look at this ante room. I'm walking in from my outside space in, and I'm standing on the dirty side of the demarcation. Well, the good news is the sink's on the clean side, so great. However, I'm also standing ungarbed in front of a negative pressure door. And so in theory, if these two doors lose pressure between them because that automatic door opener stayed open more than 30 seconds, I possibly now resonated in CFUs. Now, let me tell you, vapor pressure works against airflow because it's vapor pressure. So those two actually work against each other. So the problem with this is that the sink is actually in the wrong location. So what's the solution? It was actually easy during the design criteria. We take this door and we take this sink, and basically what we do is we flip them on opposite sides. So now the sink goes in this corner and this negative pressure door goes in this corner. I just then have to redraw my line of demarcation. So I have seen, and I was watching, I actually did a podcast, and Seth, my buddy here who's driving along, you can maybe see him. We used to have this podcast called the Pharmacy Inspection Podcast. We still piddle with it, but I did a podcast specific to this. I was one Saturday night, I'm at home, I got a glass of wine, and I'm deciding I'm going to watch YouTube videos on clean room design because I'm super cool like that, and I like to live on the edge. I'm actually a nerd. And this architect firm did this great 3D model, and they basically showed this exact same thing. Or they actually showed the sink, the hand hygiene sink, sandwiched perfectly between a negative pressure door and a positive pressure door. Now, what does that cause? It causes the air to sweep right across that sink. So any of those CFUs that are possibly created by that moisture source, called our hand hygiene sink, then in theory is sweeping from the negative side to the positive side. So if I had to put together a environmental sampling program for that pharmacy, it would be littered right around that sink and that positively pressured door to see if there's CFUs. And I guarantee at some point they're going to start to grow it in that point. So I tell you during the design criteria, everything matters. And to consider airlocks. Airlocks are actually great because what we're also finding, and the new USP 797, the 2019 version, actually mentions an airlock. And what that is that's a positive pressure break between other spaces to keep particles from resonating, or CFUs resonating between critical environments, which is really great because anytime you try to cascade, if you look at this design, this prep space and this sterile buffer, they're both negative pressure. And when you cascade multiple negative pressure spaces together, it gets real dicey from a balance perspective. So in theory, it would be nice to put an airlock, if possible, between these two negative pressure spaces to break them up and to keep any particles that are generated, because this is high risk, any particles that are generated from possibly resonating into my final buffer. So consider the airlocks as a design criteria, and I wish I had put a slide up for you on that. The design criteria is always to move the air from the ceiling to the floor so that we can sweep. That is applicable in sterile and non-sterile. Now, there's somewhat of a carve out in 797 that says, yeah, you can put a return or an exhaust grill in the ceiling if you can prove it with a smoke study. I can tell you, you can't do it. You absolutely, unequivocally cannot prove that on a smoke study. So always, 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 whether it's sterile or non-sterile, please put your grills, your low wall returns, or your low wall exhausts about 8 to 10 inches above the finished floor so that we can perfectly sweep those environments. And fan filter units are great because they have fan speed control modules, and USP 797 says we must introduce HEPA filtered air from the ceiling. I've seen too many times where somebody tried to use a filter bank upstream of that room to try and create ISO 7 in that buffer, and it won't happen. So the good news is that USP 797 says HEPA filtered air must be introduced at the ceiling. And we're still having these conversations, but that's very, very important to remember for your clean rooms. Measuring pressure. So the interesting thing about USP 800, and we're coming up on our time limit, the interesting thing about USP 800 is that it doesn't actually say that you have to measure or monitor the negative pressure for an 800 non-sterile environment where you're doing your HRT capsules and creams and stuff like that. But my question is how do you know it's between 0.01 inches to 0.03 inches of water column? If you say, listen, we're not doing a clean room, we're doing non-sterile only, you still need to be monitoring that environment, because if I were a regulatory state board inspector, whatever it was, and I was going to say, how do I know that room is between 0.01 to 0.03? How do I know it's under negative pressure? And the comment that I got back from one of my friends, like, oh, well, the HVAC guy told me. I can't take his word for it, guys. I got to have some way to prove that, right? So you need to be monitoring these environments with room pressure sensor monitors. And I think this is the last slide, and I feel like I've kind of really drugged this thing out. And I apologize because I'm very passionate, obviously, about what I do. All the details matter. All the details matter. And these are pictures. Every picture that you see are the pictures that I've taken throughout my years of adventures. Now look at this. This is a sink in a clean room. The cap's gone off, right? So I don't know what's happening in this space. I can't clean all of this. You can tell I actually haven't cleaned. And look at this rust. This is my shut-off valve. Be careful about those things. So I implore you to walk around your facility and just look to see what's going on. And look at this ceiling tile. This ceiling tile is actually not laying flat. So I would say that's a crack and crevices. So they need to go in and either clamp, they actually need to clamp that and caulk that. And then what's the problem with this exit sign? And I would typically pause and wait for a comment from the audience. And obviously you can't do that. I can't clean behind that at all. So this is actually a clean room. I cannot clean behind that. So you actually need to be hanging your exit signage from the ceiling, giving me a 360-degree perspective to be able to clean from that. This is actually wall mounted. You need to hang it from the ceiling. So all the details matter that go into a clean room, that go into a compounding environment. What we do not need, even at a 503A level, is we do not need an FDA or a state board or regulatory, or say that you're also going for accreditation. We don't need them finding any reasons to write something up or making us feel inadequate about the job. So I ask you, pay attention to the details, because your architects and your engineers are wonderful people. Your GCs are great folks. They work hard for a living. Your HVAC people, but they don't know about the details that you and I know about. And so we really have to guide them and coach them through these processes. So I think that's it. Yep, that was it. So I feel like I went through that kind of fast. I really feel like I threw a lot of information on the table there. It's a lot to take in. So here's the deal. That's my email address. I know not everybody wants to comment on the chat board. I don't see anything popping up unless there's something that I'm not seeing, another chat board maybe, but I'm not seeing any questions pop up. So I'm going to pause for a minute. But you can always just email me and say, listen, can you explain that gypsum back tile thing one more time? Now, why not a paper back tile? Or why vinyl flooring? Help me understand that a little bit more, because we want to make sure that your environments are compliant. That's the whole purpose of this online form that we've got going on now. So I'll pause and see if there's an admin or somebody waiting to speak as well, if anybody wants to put in questions.